Thanks for joining today. I'm Raj and I will simplify different tools and features of Azure DevOps in this video. There are multiple chapters. If you are interested in any specific chapter, feel free to jump on it. Let's start cracking on. A software development team is a combination of back-end engineers, quality, front-end, DevOps, and Scrum Master. To enhance their productivity, collaboration, and make the project successful, they need a number of tools to work with apart from the editor such as Visual Studio. For distribution of work among team, project status and the tracking, a project management tool is required. For collaboration and the source code, we need version control. For managing external and internal libraries of packages, an artifact repo is required. For deployment of application and infrastructure, CI/CD tool is required. For storing and running test cases, an automation testing tool is required. There are lots of tools available in the market from different vendors. You can buy them and then spend time to integrate. Or there's another option. Microsoft provides all of these tools in a single umbrella called Azure DevOps so that you can seamlessly integrate these tools. As shown on your screen, project management tool is called Azure Boards and source control is Repos. Azure Artifacts for artifacts, pipeline for the pipeline tool. Azure DevOps or ADO got two flavors. One is Azure DevOps Services, which is SaaS based, and Azure DevOps Server, which is on-prem based. You can access all of these tools through your web browser. Azure DevOps is free to try on. Just open the URL visible on the screen and sign up using a Microsoft account such as GitHub, Outlook, or Hot. ADO is software as service. Multiple consumers across the world is using it. So how would you privately and uniquely create your own tenant on ADO? In Azure terminology, it is called an organization. Organization name should be globally unique. Now, as within organization, there are multiple departments and therefore multiple projects. Within one organization, various departments and teams can have their own projects. Each project has its own unique independent instance of all the services we discussed. For example, project A will have its own instances of all the 5 services, similarly B and C. And there is no sharing allowed unless you want it. Here is an example. So there are 3 projects in New York Bank. New York Bank is an organization. And within it, we have mortgage project, data analytics, and the platform engineering. Is Azure Cloud subscription a prerequisite for free account? Absolutely no. But if you're using ADO for professional purposes for your organization, you must buy an Azure subscription, which acts as a billing account for ADO. Let's have a quick interface demo. Let's open the ADO interface. So if you see, I already have an organization here. Right. To create a new organization, we have to click on the create new organization, continue, and I can enter, for example, Bank of England. Your project will be hosted in, let's say, Canada. And continue. Now you can see a new organization has been created. Now you can create one of your project. Let's create a platform engineering project. Now this project has been created and you got instances of all the services here. There could be a situation when you don't need one of these, right? You can customize it, go to the project settings, and just toggle it. For example, I don't need test plans and I don't need repos. And go back to our project and those are gone. And if you go to the settings again, yeah, you see service connections here, agent pools, which we discussed earlier. If you see in the agent pools, we currently have one default pool and Azure pipeline. Azure pipeline is Microsoft hosted pipelines. I mean, so Microsoft hosted agents. That's all for a demo. Azure Repos. As multiple developers work in a team on different tasks and stories, to ensure they don't lose any code in event of machine crash or lost or code override, they need a central storage system to store the code safely. This is where we need a version control system. It's a central repository for the code files because source control is especially made for code files to make sure every change is being made is recorded. For example, if developers save or push a file 6 times in the repo, it creates 6 versions of that file so that you can go back and see what changes were made each time. So it helps in collaboration as multiple dev can push their changes without worry. Azure Repos supports Git and TFVC. We'll discuss only Git as this is the gold standard of version control. Git is an distributed version control system where every application or microservice can have a repository. Devs can clone repository on their machine and create a branch for their changes and merge it back. Here are a list of features supported by repos. Standard branching and merging, where you can create new branches and merge it back. Pull request feature is also supported, where developers can ask reviews before merging the changes back to the main branch. Branch policy, this is a very powerful feature. So you can ensure that minimum number of people are reviewing the code before merging. Ensures that the comments has been fixed. You can limit the merge type, for example, it should be forward or squash only. Include specific reviewers, for example, the architect or lead. And you can also specify, for example, there should be no direct commit on the main branch, always via PR. So with these features, you can control the quality of your code. You also support code level application vulnerability scanning like SQL injection et cetera. This is a premium feature, so you need to have a Azure subscription for it. Vulnerability scanning, as you know, we have a lot of artifacts. For example, the dependencies in our code, third-party dependency as well, right? So to make sure that those third-party dependencies are not introducing any vulnerability in our code, a scanning is required. So Git also, Azure Repos has also premium feature where you can have this feature integrated. Pipeline integration, so whenever a change happens on the Git repo, it can trigger a pipeline to ensure that the code is building, quality is there. With enterprise grade security, you can have RBAC control based on your Active Directory integration, TLS, automatic code reviews, enforced coding standards. These all are supported. Secret scanning, it can check if developer mistakenly checked in a password or a key secret in the code. It's powerful, isn't it? You can also use GitHub in place of Azure Repos. It's also fit well into the ADO ecosystem. Azure Artifacts. What are artifacts? Let's discuss about the artifacts first with some examples. This is a package requirement of a .NET project. Similarly, on the right is an NPM package requirement of a Node project. Each of this package represents dependency of specific project. These dependencies are called artifacts. This makes Azure Artifacts a package management system. Azure Artifacts supports NuGet from .NET World, npm from Node-word, Maven and Gradle from Java, Python and pip, and Cargo from the Rust. By now you must have understood that Azure Artifacts' primary use is package management. What if you need to store your build artifacts containing your website or microservice binaries and the config into Azure Artifacts? The answer is universal packages. You can keep any file format in this package like .zip or .tar. Azure Artifacts doesn't support container images. As I mentioned, its primary use is package management system. If you need to store container images, you have to use a container registry, could be by Azure or AWS or any other cloud. What are the build and the pipeline artifacts? Pipeline artifacts are not part of Azure Artifacts. It's only used in Azure pipelines, and the artifacts produced by the pipelines are stored within some managed system by Azure DevOps, which is totally different from Azure Artifacts. You don't have to be confused with these two concepts. In a typical application build, application source code and dependent library packages are required. Building of an application can produce two kinds of output depending upon need: application binaries or a package. Package is supposed to be used by other application. It can't be deployed on its own. Now question arises, where would we keep this package to be used by other application? So that when npm install is used, those packages are downloaded during build process. What is the option here? Public npm package manager available on the internet as shown in picture. But do you think an organization want to keep their private package on an internet repository? That's where we need a repository like Azure Artifacts, where organization can store their private packages. Now let's talk about another problem. Public packages are being downloaded from internet. What if connectivity to that repo has some issue? Or repo is down due to some cloud outage? Then your build process won't be able to download those packages and the build will fail. How can we mitigate it? So Azure Artifacts has another feature where you can source public package directly from the internet via Azure Artifacts. And during this process, Azure Artifacts also cache those packages in its local storage. Here you see when packages are cached in first build, next build onwards, all the packages will be sourced from Azure Artifacts. No internet connectivity is required. Let's talk about the scope of the feed. As we discussed, there are one organization. Can one feed be shared by multiple projects? Yes and no. So there are two kinds of scope here: project scoped and organization scoped. The project scope fields are only accessible within the project, but organization specific feeds are accessible by other projects as well. As we discussed, organization has multiple ongoing projects at the same time. Depending upon the need, you may allow feed to be accessible only within a project, or all the project within an organization, or only with the chosen ones. Public feed is another mechanism where you can share your package with some other organization or over the internet. Public feed can only be created inside of a public project. Let's have a demo. Let's have a look of Azure Artifacts now. So you can see on the right there are three organizations. I'm going to use the content API and the project is web portal. I'll just click on the web portal and open the artifacts here. So I have already generated a NuGet package and it is stored here. You can see the version here and how to install in your .NET project. So it was generated via pipelines. So I already have a pipeline which is generating it. So artifact versions are immutable. So if you have created one package with the same version, you can't create it again. So if you delete it, don't delete it permanently. Keep it in the recycle bin so that if required later on you can undo it. because if you deleted it, you have to increase the version to recreate this package. That's all, and you can see this package is currently project scoped and have another feed which is organization scope. I don't have yet anything here. So for example, this is content API and the project is web portal. Let's go back and open this project and artifacts. If you see, organization scope field is visible here, but not the project level field. Azure Pipelines. Azure Pipelines allows DevOps engineers to create CI/CD pipeline to automate builds, testing, and deployment of code. It supports all major languages, platform, and cloud. Let's first check how a developer builds their code manually. All of these steps are executed by a developer on a machine. So they install the required framework like .NET, Java, or a Node, starts the build on their machine, then dependent libraries are downloaded, the test cases are run, and finally binaries are generated, and those are deployed to a local server. Now let's try to map these manual steps to automation pipeline step by step. Developers started the build. This is equivalent to a trigger in pipeline terminology. There are multiple triggers. Example, push to a repo. Whenever dev push a code to a repo, pipelines can be triggered. Similarly, when a PR is raised and a pipeline is triggered on that merged code. So this is temporary merge to run the pipeline. Manual, someone goes to the UI and click the run button. Schedule. For example, you want to run the pipelines every day after another pipeline. For example, when CI pipeline is finished, you can trigger the CD pipeline automatically. So that's how trigger works. And then code checkout on a machine. In this step, code is checked out by developer. The pipelines are just orchestrators. They don't have computing power to execute the steps we mentioned earlier. So pipeline needs a machine to execute those steps. So this is where agents come into picture. Agent is nothing but a VM with an agent software on it, which helps in communicate with the pipelines for build status, availability of machines, and to run the tasks. You can have your own set of VMs on Azure cloud or any other cloud, or Microsoft provided machines. So Microsoft is then maintains those machine, update patches, etc. Or there is an option of Azure VMSS as well. In VMSS, machines are provisioned based on the load. If there are a lot of pipelines are waiting to be executed, VMSS can spin off new agents, run those pipelines, then for unprovision them. These manual steps now needs to be automated. That's where pipeline YAML is required. These manual steps are coded into YAML file for executing these without any human involvement. This can be converted into either two pipelines with a separate CI and CD, or we can have a combined pipeline where CI and CD steps are written in a single YAML. Anatomy. YAML pipeline is hierarchical in nature. Hierarchies at first level, we have stages. Stages contain jobs and job contain tasks. Stages help you to organize your pipeline into logical sections. They provide better clarity and the control over your CI/CD process, allowing you to apply approvals and condition at each phase. For example, when you deploy to the production and you need approval from architect or any business owner, that can be applied on the stages. So the deployment will not happen until someone explicitly approves it. A stage can have one or more jobs. Jobs are a unit of work that run on an agent. Basically, they're a group of steps that execute sequentially on same agents. You can target different jobs on different agents for parallelism as well if required. For example, you have 3 jobs and they can be running parallelly. And that happens at the job level only. Tasks are the actual worker who works at low level like developers. Example, this is a predefined task where you can download key secrets from Azure. Similarly, there are hundreds of ready to use tasks available. All are open source and available on the GitHub. If there is no predefined task available, you can write your custom script as well. Anatomy of ADO pipeline. So here are two sample YAML pipelines. Let's start with the left one. So you have stages here. We have three stages: build, test, and deploy. Build stage has jobs and it has only one job, which is build. And the test stage has two jobs. Then, as we mentioned earlier, job runs on a agent. So we have mentioned which agent is required here. In the pool, run this job on a machine which has Ubuntu latest image. And then we have its steps. So this is script 1, script 2. So these are two separate steps. And if you have noticed, there's another keyword depends on build. This causes these stages to run sequentially. So test will not start until build is successfully complete. If you don't have depends on, so these two can go parallel. Now on the right side, it starts with a trigger. It means when our code is pushed to main via PR review merging, this pipeline will be triggered. It doesn't have any stage mentioned here because there is only one stage. So when there is one stage, it is optional. You don't need to mention it. And similarly, it has everything which we already discussed, but it is using tasks here. So we have using a predefined task, which is node version they want to use. It will be installed. Then there is a custom script to install the npm packages. Npm test, again a script command. We have already discussed triggers, stage, job, and task. Here are a few more concepts. Starting with parameters. Parameters are used for customization of pipelines. For example, using same pipeline to deploy to dev and QA via passing appropriate parameters for environments. In the pipeline parameters on your screen, so image is a parameter here. So same pipeline can be executed on three different agents using parameters. You can select Windows, then run this, and it will run on Windows, then Ubuntu, Microsoft. So you have to run it a few times if you want to run on three different pool images. These parameters are immutable. They are set at the beginning and can't change during the run. On the other side, variables are mutable and can be defined at multiple levels, including pipeline, stage, job, and steps. All variables are string. The value of variable can change from run to run or job to job of your pipeline. For example, you want to compute some value, build number with current date and time. You can use variable, compute this value, then use it wherever you want. System variables, there are a lot of system variable available. That's one of the variable I have mentioned here, build.build ID. So whenever you run a build, a unique build ID is generated. So if you want to log it or want to use it, so you can use it via system variable. Environment variables, as application you are building, might rely on environment variables during builds. So environment variables can be used to pass values to the application. For example, your application need to connect to S3 and they need credential. So environmental variable can be used to pass those credentials to the application. So sometimes we have a requirement where variables and secrets need to be used by multiple pipelines. That's where variable groups are used. Variable groups are stored in a central location and can be referenced by pipeline. So when you change it, when you need to change it, you can change it to the single location. Now all of the pipeline will get that change. Now here in a sample, we have Azure secret group already defined and we are fetching in the pipeline. So for example, your 10 pipelines are now using it. In future, if there is change in secret, you have to use it in the single place instead of modifying 10 pipelines. Agent pool, as discussed, is set of machine used to run jobs. Service connection is configuration that securely store information required to connect and authenticate to external service or resources. Example, you have a need to connect to Azure, Vault, ECR, GitHub. So you can create a service connection where you mention the URL, credential, keys, etc., whatever required in a single group. And in the pipelines, you just mention that service connection to create a connection. Now let's connect the dots. Developer push code into Azure Repo. Azure Repo notifies the pipeline that a commit has happened. Pipeline checks in the pipeline YAML if that trigger is configured for main branch. If yes, pipeline is triggered. But to execute pipeline, a VM is required, a agent is required. Now, pipeline needs to check if required VM is available or not. For example, middle VM is available, a job is scheduled on it, then steps are executed on that particular VM, and then execution status is sent back to the pipelines. Now this particular job is completed. Now this VM gets freed and it can be used to run next set of jobs. Let's have a demo of pipelines. So I have web portal project opened. Now I'll click on the pipelines, and if you go to all, you see I have only one pipeline here. This pipeline generates a NuGet package. Whenever you run a pipeline, it represents a one run. So each run is given a different number, a build number. For example, you see this is date wise. On this date I ran the first, and on this date I ran the second, so it acts as a run number. So I have run this pipeline 15 times total, right? And 14 times on 2nd of May, and single times when I got a success on 3rd of May. You can go in the pipeline and check what all has happened. I have only one job here, and this is how good it looks. Right, and you can here click run new. You can select the branch, and if you have multiple stages, you can choose whatever stage you want to run. I don't have any stage here. And if you want to debug log as well, you can click enable system diagnostics and run it. Meanwhile it's running, let's go back and see. Yeah, so you see this pipeline is running, and you can see the live logs. Let's go to the pipeline and see how we attach a YAML here. So I already have this pipeline. When I click on edit, it will take me to the YAML pipelines. Yeah. So you see I have trigger on the master, 3 variables. They are my steps. Step 1, step 2, step 3, step 4, and step 5. All these steps, if you have noticed, were visible there. Click on it, click on job. See all the 5 steps. So checkout is of course default one, and 1, 2, 3, 4, 5. All 5 tasks are here. Okay. Go to the pipelines. You can create a new pipeline here. And where is your code? For example, you have Azure Repos. Select it. Which repo you have your code. So select the repo. It's got a pipeline. Example this one, and select existing pipeline and the path to the pipeline. So you can select this and continue. It will create a new pipeline. I'll click save. So I have now 2 pipelines. I can go and rename it. And save it. You can also create folders and arrange and manage your pipelines from here. Yep, that's all for pipelines demo. I'm super excited to announce that I will upload a production grade series on Azure Pipeline soon. Stay tuned and subscribe for more videos.